In this demo, we will see a physical camera being integrated into SmartX. The camera we're using here is a 4th generation Luxonis Oak-D camera, which is a spatial AI and computer vision camera. It is a standalone device perfect for robotic vision and automated systems, since it can capture color and depth information and has on-device computer vision and neural network inferencing capabilities. So we can build a complete pipeline for capturing, processing, and analyzing images and set it up to run entirely on the camera. For this demo, we have set up a pipeline as shown in this high-level block diagram. This pipeline continuously captures a color image, detects QR codes in the image using a pre-trained neural network model, decodes the QR codes and publishes the outputs and also the image to MQTT. We can see that in the MQTT Explorer here, which shows the two topics that are getting data from the camera. Right now, there is no QR code in front of the camera, so the list of outputs being published is empty. But if a QR code appears in the field of view of the camera, and I'm now placing a bunch of QR codes in front of the camera off screen, then the outputs will start appearing in the MQTT topic, as we can see here. Now, if we open SmartX Cloud, we have a device set up for the Oak-D camera with some data variables. We have two measured variables defined here to capture the data generated by the camera. That's the image and the QR outputs. The other two are virtual variables that are defined for the purpose of generating visualizations. As we can see, the camera setup for this demo is already smart, so once it is set up on SmartX like here, it can be used by any process without any more effort, and that process will have available the captured image and the detected QR codes. But just for the sake of this demo, we also have a device script created for the camera. This script takes in the image and the QR outputs generated by the camera, overlays the location and decoded text of every detected QR code onto the image, and saves it into the corresponding device data variable. Then there is a device controller defined for the camera, which simply assigns the device script to the running lifecycle. This means that anytime this camera is used by a process, the process will receive the updates generated by the device script. For this demo, there is a simple process config set up, and all it does is run a script that consumes the camera's outputs, and it does this for 10 minutes as dictated by this timeout end case. So the process config here isn't really set up to do anything apart from read off the Oak camera device. Now let's open the HMI, and here we start a process session using our process config. Once we authorize it and the process starts running, the device controller for the Oak camera starts executing the device script, and the dashboard starts displaying the images. The dashboard setup for this demo shows the captured image and a result overlay image with any detected QR codes marked up. As there currently isn't a QR code in front of the camera, there's no overlay displayed in the result image. Now, when I place some QR codes in front of it, as we can see, the result image shows the QR code locations and decoded text. So really we can see, based on this example, how easy it is to integrate a smart camera, which is an edge computing device, into SmartX. In cases where additional functionality is desired, SmartX's device scripting feature allows us to add that, as demonstrated by the overlay images in this example.